Chapter 8, Storage Services. Chapter 8 covers AWS storage services, with the main focus on Amazon S3, Amazon EBS, and Amazon EFS. It also places S3 Glacier, AWS Backup, Storage Gateway, Amazon FSx, and the Snow family into the wider architecture picture, so you know where each service belongs without turning storage into a random list of products. Storage is one of the most important architecture decisions in AWS because almost every system depends on it. Applications need somewhere to store files. Databases need durable volumes. Analytics platforms need scalable object storage. Users may need shared file access. Enterprises need backup, archive, recovery, migration, and retention strategies. The mistake is to think of storage as one generic thing. In AWS, the right storage service depends on access pattern, performance needs, sharing model, durability, recovery expectations, and cost. Amazon S3 is usually the most important storage service to understand first. S3 is object storage. It stores data as objects inside buckets and is designed for massive scale, very high durability, and broad integration across AWS. It is not a normal file system, and it is not block storage. It is better understood as a durable object platform for files, logs, backups, archives, data lakes, static assets, exports, and integration workflows. S3 matters because it becomes the storage foundation for many modern AWS architectures. Static websites can serve assets from S3. Applications can store uploads there. Analytics systems can build data lakes on top of it. Backup and archive workflows often land in S3. Machine learning and data processing pipelines frequently use S3 as their common data layer. It looks simple at the surface, but serious S3 architecture includes bucket policies, IAM, encryption, lifecycle rules, versioning, replication, object lock, storage classes, event notifications, and monitoring. A senior engineer should also understand that S3 is evolving beyond simple object storage. Modern data platforms increasingly use S3 as a structured lakehouse foundation, with formats such as Apache Iceberg and services such as Glue, Athena, and Lake Formation around it. That deeper analytics angle belongs later in the Analytics and Data Platform chapter, but it is worth remembering here. S3 is often the storage base under both application data and analytical data platforms. Amazon EBS, Elastic Block Store, solves a different problem. EBS provides persistent block storage for EC2 instances. If S3 is object storage, EBS is closer to a virtual disk. It is used for boot volumes, application volumes, databases running on EC2, transactional workloads, and systems that need low-latency block-level access. EBS is attached to compute and behaves like storage. The operating system can format, mount, and use directly. The important distinction is that EBS is tied to an availability zone. It is durable within that zone, but it is not a regional shared object store like S3. This makes EBS excellent for EC2-based workloads that need predictable performance, but it also means architects must think carefully about snapshots, replacement, restore behavior, replication, and recovery. EBS volume type matters as well. General-purpose volumes fit many workloads, while provisioned IOPS or throughput-optimized choices may be needed for heavier database, streaming, or storage-bound enterprise systems. Amazon EFS, Elastic File System, is the shared file storage option. It provides a managed NFS file system that can be mounted by multiple compute resources. This makes it useful for workloads that expect shared file semantics, such as lift and shift applications, shared content repositories, home directories, media workflows, or systems originally designed around network file shares. EFS is elastic and managed, so capacity can grow without the same manual volume planning associated with traditional file servers. EFS should not be chosen just because shared storage sounds convenient. Shared file systems can introduce coupling, performance assumptions, locking behavior, and operational complexity. But when applications genuinely need file-style access from multiple instances or containers, EFS is often the right managed choice. It fits especially well with EC2, ECS, EKS, and selected serverless workflows where shared file access is required. Amazon FSx exists for more specialized managed file systems. It is the place to look when EFS is too generic or when the workload expects specific file system behavior. FSx for Windows File Server supports Windows native file shares. FSx for Lustre supports high-performance workloads such as HPC, analytics, and machine learning. FSX for NetApp ONTAP and OpenZFS supports more advanced enterprise file system patterns. FSX is not the default for every workload, but it matters when compatibility, performance, or enterprise file system features drive the design. S3 Glacier is for archive storage. It is not where you put data that applications need immediately all the time. It is for long-term retention, compliance archives, backups, audit data, and infrequently accessed historical information. The trade-off is retrieval behavior. Glacier can be very cost-effective, but only when the workload accepts archive access patterns. A senior engineer should always ask how quickly the data must be restored, not just how cheaply it can be stored. AWS Backup gives a centralized way to manage backup policies across supported AWS services. Instead of treating backups as a side script per workload, AWS Backup lets teams define backup plans, retention rules, vaults, copy strategies, and cross-account or cross-region recovery models. This becomes especially important in governed enterprise environments where backup consistency, auditability, and restore testing matter. Storage Gateway connects on-premises environments with AWS storage. It is useful in hybrid architectures where local systems still exist, but the organization wants to use AWS for backup, archive, file storage, or cloud-backed storage workflows. It can help during migration and can also support long-running hybrid setups. The Snow family is about physical data movement and edge scenarios. When data volumes are too large, networks are too slow, or locations are disconnected, Snow devices can move data into or out of AWS physically. This is not everyday application storage, but it matters for large migrations, remote sites, field operations, and offline transfer problems. A senior engineer should remember that storage architecture starts with access pattern. Use S3 for durable object storage and data platforms. Use EBS for EC2 attached block storage. Use EFS when multiple compute resources need shared file access. Use FSX when the file system itself has specialized requirements. Use Glacier for archive. Use AWS Backup for centralized recovery governance. Use Storage Gateway and Snow when hybrid or large-scale movement becomes part of the problem. The bottom line is simple. Object, block, and file storage are not interchangeable. The right storage choice improves reliability, performance, security, and cost. The wrong choice creates hidden limits, operational pain, and expensive redesign later.